Welcome to the UGC lecture series. In this lecture, we are going to talk about file organization. Up to now, we have looked at small pieces of data and how it can be stored. In this lecture, we are going to look at complete details of records and files and directories that are going to be stored. This is a very important aspect of many applications of computer science. Database management systems works with files. Now, we are going to look at the data structure aspect of how file is organized and accessed. So, if you look at the what we are going to talk about here, we are going to first look at how remember that files are generally stored in external memory, that is it is stored in the secondary memory and disk, hard disk. Hard disk is one of the main secondary memory devices. So, we are going to look at how a hard disk is looks like and how it is organized. Then we are going to look at how files and directories are stored, what are files, what are directories, and how they are organized, and then we are going to look at how these files and directories are going to be allocated to the secondary memory, to the physical memory device, and then we are going to look at how it is accessed. Allocation of physical memory space is one thing, accessing that data is another thing, and then we are going to look at a small introduction of sequential files in this lecture. So, let us start off with how a physical file will look at. Now, if you look here, this is a typical file physical disk structure. It consists of many disks, which in this term is called as platter. This is a platter, this is a platter, this is a platter, this is a platter. So, in this example, we are looking at 4 platters. Each platter has got surfaces, which you can see here. This is the surface of the platter, and then associated with each platter, now I am going to talk with respect to this, each platter you have a number of tracks. Here we have shown only one track, you can have track like this, and you keep on having tracks like this, okay. So, those are tracks, they are nothing but circles inside the platter. Then each track is associated with a sector. So, you will have number of sectors on a track. Let us assume that this has 10 tracks. Then if you say the 9th track or 8th track here, 8th track here, 8th track here, 8th track here, all these tracks together form what is called a cylinder. So, the cylinder is only a notional aspect, it is all the tracks of the same number across the different platters. Then you have, now this is as far as the physical device is concerned. Now, if you want to store data and access data, you have to have a cylinder reading device, okay, and that is called the that is this, and it has an arm and it has a head. Now, this arm can move in and can move out, okay, it can move in and it can move out, okay, and when it moves in, it will access the same tracks in all the platters. So, when this moves in, it for example, it reaches this point, it will access this track, this track, this track, same track of all the 4 of the same cylinder as it is called. And this is the arm. So, this arm is for moving in and out, and this is the head, which is for reading. Now, if you take if you have stored data in this disk, what actually happens is, first you will have to move this arm and you will have to seek the correct track. So, that is called the seek time, this getting the correct track. So, it depends on how much time it takes to move in and move out. So, suppose you are in the this track, then if you want to move to this track, it takes some time, that is called the seek time. And then once you have reached the correct track, you have to reach the correct sector, that is this has to rotate, this is a rotational latency time. So, to reach a track it is called the seek time, to reach a sector it is called the rotational latency time. These two together is actually the data access time. So, the access time is nothing but the time taken to reach the particular track, the seek time, plus the time once you have reached the track, the disk rotates, and to reach the particular sector, that is called the rotational latency time. So, these two together is the access time. Now, why are we talking so much about this access time? Now, depending upon how you have organized your files, the time taken to read those files and write those files is going to vary. So, if you store one data in this sector, let us for example, and another data in some other track in some other sector, then the time taken to read that data which is stored across tracks is more than the time taken to store, if you have stored the data sequentially here or near each other, then the time is going to be less. So, this is the basic aspect of file organization, that is how we are going to organize the data inside the disk or inside organize the data, physical data. So, before we go to that, let us look at what we mean by a file. Now, it is nothing but a named collection of bits, and usually it will be stored on a disk, and it has some properties. It will have contents, it will have size, it will have an owner who owns this file, it will have a last time that you have read or written onto the file, it will have a protection, write protection, read protection, and it will be a type of file like it is a direct access. We will come to this type later. Then this is from the file as a data viewpoint. Now from the OS viewpoint, a file is a bunch of disk blocks on a secondary storage device. Now what I mean by this disk block is, normally you do not read record by record. Okay, suppose you have a file of 10,000 records. Now you do not read first record, second record, third record and assume that it is stored in different places like that. If we do not do it like that, what we do is we divide the file into blocks. Okay, blocks, and these blocks are read together. The idea is that all the records of this block will be in the same area, track and sector wise. So that you read a block, you write a block. So all that, so that block is very important. And as far as the OS is concerned, we are bothered only about these blocks. So from OS viewpoint, a file is a bunch of disk blocks on a secondary device. Even if a file is used at a higher level of abstraction like records and byte streams, it does not matter to the OS file management system, because as far as the OS is concerned, it sees only blocks. Now a file's type, we said that a file can have a type. The file's type can be encoded in the file's name or in the contents. For example, the type of file can be .com.execute, this is an executable file, batch file, this is a MP3 file, and so normally it will be encoded in the name itself as a dot extension, or Unix has smattering of both. In content via magic numbers or initial characters will indicate that what type of file it is. And normally the files are managed by something called the file system or the file management system. So before we go further, let us look at files are not just like you do not have 350 files all together on your system. It is organized into directories. So what are directories? These directories are provided by most operating systems for organizing files. So a directory performs the same function as a folder in your filing cabinet. So a folder will contain all the files related to that particular topic or whatever. So suppose you are talking about leave applications, all leave application will be in a particular folder. So this folder, in computer science terms, files, and you have files have records, and files will be stored in a folder which we call as directory. And however, directory in most operating system is represented as a special type of file that holds information about other files. So actually this directory itself is a file only, but it will have information of other files. So it serves as an index and tells the operating system that files are located in the auxiliary storage device where it is located, and also information about the file in its contents, such as who has access to the file, the date in which the file was created, and who can access it, accessed when it was last accessed or when it was last modified. All this information can be available in a directory. So again, just to directories provide a way for users to organize their files, as we saw, and a convenient file name space for both the users and the file systems organization. And most file systems have a multi-level directories. It is not that one level directory, it has a hierarchical structure of directories. For example, slash could be the root, slash user could be within the root one level, after that one level, this could be 2 levels, this would be 3 levels, and so on. So you have multi-level directories, and you also, the most file system will tell you which is the current directory in which you are operating. So it has a notion of the current directory, and a directory is typically just a file, but that it contains metadata. It is a list of name of files and file attributes. If you look at a computer in your desktop, for example, in your system, and then you can see that it tells you which are the folders available, and inside the folders are directories. Inside the directories it will tell you the file names, it will tell you the date on which it was created, it could tell you where the path name to go to that. If you go for a search, it could tell you what is the size and all that. So typical attributes in the directory which is associated with the file is the size, what is the protection, where location on the disk, creation time, access time, and so on. You can have, it depends on what the file system is supporting. Now this is the directories in a typical Unix operating system. In Unix, the directory system is organized like this. You have directories and you have files. So this stands for directory, this stands for file, and then you have a root. This is represented normally by the backslash. Within the root, you have 4 types of, you can have many types. Some of them are bin, user, DV, development, etc., miscellaneous files. And within user, he shown only that example. You have bin, staff, spool, many others also. And then within staff, you have Adams, Joan, some Tran, Zyke, and so on. And at any level, you can have files. So suppose you want to access these files, you have to say / user, staff, Adams, file 2. Then you will access this file. So that is the way the path is specified. This is a directory system of Unix. And there are in Unix, if you take, there are 4 special types of directories that play an important role in the directory structure in US. They are the root directory, the starting point, home directories, working directories, and parent directories. Okay. So these are some of the directories that Unix specify. And the file's path is specified in absolute path name, that is, you start from the root and tell the complete path name, or you can give a shorter path name in terms relative path name. It is called as relative path name. This is what it means is relative to the specific working directory that you have. The working directory is the one from which you are accessing, or the current directory is the working directory. So, for example, suppose you were already in Joan directory, then Joel/file3 will give you the, you can go. Suppose you want to give the absolute path name, you have to start from the root, go to user, staff, Joan, file3. So, this is the relative path and this is the absolute path. So, this is the elements of a typical file management system. We are looking at two different aspects here. One is the file management concerns and the other is the operating system concerns. So, here you will first talk about the file management concerns. You have user and program commands to access the file, and then you have here the directory management, and here you have the user access context, and then you give the operation that you want, like say create a file, delete a file, insert a record into a file, and so on. So, whatever the operation and the file name, it will go to the file structure and then it will decide on one access method and it will do the file manipulation function and to the records available. So, this records has to be accessible by this. This is as far as the file management concern is concerned, we are talking about different records. You delete records, you insert records. Okay. So, the accessing or the granularity at which you are accessing the file system is records. But as far as the operating system is concerned, it does not see records, it sees only blocks. So, here you do the blocking. Here you have free storage management. This is the physical memory in physical blocks that are available in the secondary memory. This is physical blocks that are available in the main memory. Now, when you talk about storage, you have you can operate on the file records only if it is in the main memory. So, why are you using the secondary memory? The secondary memory is used for storing. Obviously, the basic assumption is that you have lot of secondary memory and you have less of main memory. So, what you do is main memory, let us assume, has 4 blocks and only, this is just an assumption. So, you just can accommodate only 4 blocks, and the secondary memory can accommodate any number. So, when I want to process, this 4 blocks will be here, and so what happens is you have to do some scheduling to decide which block to take out to accommodate a new block, and that is done here. This is the IO of the operating system, and after that you can access this. So, this is the operating system part, this is the file management part of a typical file management system. So, after the file we talk about record. Now, in record you have fields. So, you can have different type of fields. Look at this, the field is the smallest unit of the application data and the field can be a simple attribute. So, decisions have to be made, what is the storage type, what are the data integrity rules, what is the display format and so on. This is basically to do with database management issue, but just to show you how a data structure has to be designed for this is why we are talking about this. So, when we talk about files and records, we talk about physical organization and logical organization. So, in a logical data model, you group a record into those attributes, and the attributes and which will be determined by the primary key. For example, here the primary key could be the name, and in contrast the physical record is just a group of fields that is stored in adjacent memory locations and which can be retrieved and which can be manipulated by a database management system. The physical system does not know anything about whether it is a primary key, what is it, what is the logical meaning of those records, all that the physical memory does not know. But then we have to organize it in such a way that this physical memory gets translated to the logical memory, and when the database management system is manipulating it, it does not know anything about what is happening in the, how it is actually physically allocated or how it is physically accessed. So, the physical storage allocation is one important aspect when we talk about file organization. The file manager has to work with files and not whole units or blocks. So, records within file we will assume we have the same format, but they may vary in length, and as we have seen already, records are subdivided into fields. When we talk about file storage, we are actually talking about how the different records are stored. So, when we talk about allocation methods, there are 3 types of allocation methods. One is contiguous allocation, one is linked allocation, and one is index allocation, and depending upon what allocation you have, the access methods will be different. Contiguous means continuous allocation, that is all the records will be stored one after the other in continuous physical memory storage allocations. Linked means physically they may not be adjacent to each other, but there are pointers to link them, and indexed means we have a separate place where we give the the important primary key and where it points to. So, we will see this in detail as we go along. So, first let us look at contiguous storage. Here records are stored one after the other. So, if you know the starting address and you know the size, you can just read the record. It is the simplest method, and this makes direct access very easy. Every part of the file can be accessed easily directly. So, the problem with contiguous storage is that it cannot be accessed unless there is remaining memory locations immediately following it. So, room must be provided for the expansion when the file is created. Suppose you have 100 records file and you think that there will be about 50 records insertion, then you have to allocate 100 plus 50, and that prediction you have to do. The problem here is something called fragmentation. This is a concept that comes in our operating system also. I mean the same thing is dealt with. This is actually small parts of unused storage space which are distributed over the whole physical memory, such that you are not allowed to use that because it is not available as a contiguous storage. So, and one way to overcome this, you take all those small pieces and compact them together, but the problem is when you are doing that compaction you cannot access the file. So, each file occupies a contiguous blocks on the disk. You need to know only the starting location, even if it is unblocked. The previous thing we spoke about was unblocked. Even if it is blocked, the complete block will be stored in contiguous memory. You need the starting location and the length, the number of blocks that is required. So, random access, this allows for random access, but the problem as before is files cannot grow. So, suppose you have a logical, so the block to be accessed, the starting address and the displaced in the block, if you give, you can access it. So, for example, this is contiguous. So, suppose I have count, this is just a very minute view, you will not have so much less space allocated. So, suppose you have count, it is a file and it is given the starting and the length. So, 0 2. For example, let us take this one. Starting is given as male, this is starting is given as 19 and it is allocated 1, 2, 3, 4, 5, 6. It is allocated continuously, these 6 are allocated continuously. So, you are given only the starting point, the name of the file, the starting point and the length, and so you can access it. So, these are the different types of organization, physically allocation you can do for contiguous allocation. So, you do not do any blocking at all and you have fixed length records. So, R1, R2, these are say for example 4 blocks, so you just allocate that. Here it is blocked, but it is fixed length. So, you say the block address of the block, the number of records and just store it, block 2 the number of records, store it. Next is unblocked variable length. So, this is similar to this, but it is only thing is variable. So, you starting point and the length you give, starting point and length you give. So, then you can get there. Then unblocked variable length records is similar to this. Instead of giving the length, you can also give a hash symbol indicating that this is the end of the record. So, otherwise you will not know, because previously you knew it was fixed length. So, you know where the end of the record is. Here you have a special symbol to indicate the end of the length. These two are same, except the method of indicating the length is different. Here you have blocked variable length. So, you have block 1, block size, the number of records and the record length in each case. So, record length, record length, record. So, these are the different variations that you have in contiguous allocation. Now first let us look at sequential file. This is a simple file organization in which records are stored in insertion order or by key value. Sequential files are simple to maintain and they provide good performance for a moderate number of records. So, you have this is ordered according to the social security number. Next we go to non-contiguous storage, that was about contiguous. So, what is the meaning of contiguous? All these records are stored physically near each other, they are allocated contiguous memory. Now allows file to use any storage space that is available on the disk. If there is contiguous space, it will use that. Unfortunately, always you won't have contiguous space, that is the problem. So whatever is contiguous, you allot it. Any remaining records or additions to the file are all stored in other sections of the disk, not contiguously. So this is called the extents, and you can link together these different parts of the file through pointers, and depending on what the OS specifies, the physical size of each extent can vary. One of the non-contiguous is indexed. So what you do here is you have an index block in which all the you will have pointers to the blocks. So this is the index table, you need additional space to store the index table, and then you have pointers to the blocks. So this is the index location. For example, here you have index block 19, and this 19 is coming in different locations. It first comes in 9, and then it is stored in 16 and so on, 16, then it is stored in 1, then it is stored in 10, where is 10, that is the order in which it will come, 10, and then it is stored in 25. Look at this, it is not at all sequential, see 1, 2, 3, 4, 5, 6 blocks all spread throughout, and these are to say that those blocks have been, it was occupied before, it has been deleted now. So this is a typical example of index location. So the obvious thing is you need an index table, and you can random accesses. So here again you have Q and R, mapping from logical to physical in a file of maximum size and block size of 512 words. We need only one block for the index table. Now if you have here, you have to, but only thing is you have to go to the index block and then do it, and link blocks of index table, there is no limit in the size. So this is a 2-level index, you can have a 2-level index. Now the problem is that if the index table itself is too large, then that can't fit properly, you will have to search there. So for that what they do a 2-level. So for example, I have 10, 15, 20, 25, 30, 35 and so on. I say that 20 to 50 is coming here, and that I will have a separate index block. So it will be a 2-level index block. So for example, this is called, though if you have 2 levels, it is normally called as outer index and inner index or the index table. So you start from this search here, and it will be 10 to 20, 20 to 30 like that range, you go there, in that you will have all the records which fall within that range according to the key, and then this will give you the address of the actual record. Remember, these are not stored in contiguous. So this is how it will look in a memory. So this is the user space, this is the kernel memory, and this is the secondary memory. This kernel memory is the directory structure. So it will have a pointer to the file control block, and it will also, and this will have a pointer to the directory structure and so on. So this is the kernel memory, and this is the index if it's you have an index. In addition to the index, you can also have a linked association. So in the block there will be a pointer to where exactly the physical file is stored. So that is how it happens. Simple, you need only the starting address and there is no wastage of space, but only problem is you can't have random access. It has to go link 1, link 2, link 3, so it takes some time, that is the problem. And so for example, this is the starting point, then from here there is a link to 16, from here there is a link to 1, from here there is a link to this block, okay. Then there is a link to this, okay, and the end is specified. So this is a linked structure. Remember, this is physical memory, so you have to go and search for that. So this will be the file allocation table. So here the links are given. So for example, record 1, record 2, record 3, record 4, record 5 is stored like this. Link. So Smith is the starting point, Smith to Jones, Jones is stored in 4 and so on. So 3 is the head, and this is how it is done. So suppose you want to add a name here, okay, suppose you want to add a name, then you have to change the links, like this is like how we did in the linked list, similar to how we did, but remember we are doing this in physical. Similarly, if you want to delete, okay, you can do that also. So here you have deleted Jones, and that has been put here to say that this is a deleted file. So this is a create links to place the following account numbers in ascending order. So 6 these are the account numbers, it is not in ascending order. So what you do is you have the records and then you have links to the records. So linking each extent points to the next one in the sequence. So directory entry will contain the file name, the storage of the first element and location of the last extent and so on. Linking at directory level also you can do. Here inside the directory you form the links. So another very important index structure is the B tree index. So here you have index on the last name, Do, branch 1, Smith branch 2. Then you go to branch 1, you will have a pointer to branch 1, there you have the actual record pointer to the actual record. We will come to this in detail in the next. So, this is the data representation using linked list. So, you have employee, job history, payroll, education. So, employee, that will have a pointer, what are the employees, and for each you will have pointers to indicate the files. So, next let us go to access methods. When we design a file, the important issue is we have put it all in the allocation, we have done the allocation, but actually as far as data structures is concerned, we are more bothered about how we retrieve the information. Sometimes we need to process records one after the other, sometimes we need to access a specific record without retrieving the preceding records, and these access methods determines how we can access the records either sequentially or randomly. So, when you look at file access methods, there are 3 methods: sequential access, random access and index access. Read sequential, you just read one by one; random, you give a number, you can go there; index, you go to the index and from the index you have to go. So, typical operations of file are retrieve a record, insert a record, delete a record, modify, and in direct files you get a record and given field value. In sequential files, the operation is get the next record. These are the operations, data structures operations. So, sequential access, you start from the beginning, go to the end. Random access, you just give the access and go directly there. So, this is the taxonomy of file access methods. You have sequential and random. In sequential you have the sequential file, and in random you have the index file and the hashed file. We will go into this in detail later. So, sequential files are files that we have already seen, all the records will be stored and there will be a header file. It could be blocked or unblocked. So, this is the most basic way in which files are stored, and it can be composed of one record or many records. This is a simple sequential file where the records are there and there is a special indication saying that this is the end of the file. So, records are stored contiguously and they are read from the beginning to end. Very important, very efficient if you have large number of records, that is if you have large number of records and you want to do the operation on all the records like finding averages and all, this sequential files are very good. So, you have sorted sequential files and unsorted. If it is unsorted, it is called as pile files. So, if you want to search for sorted files, you have to just look up a record, the average time is b by 2, and if you want to read and process all the times, it is very good because you can just go one after the other. And sorted files are usually read sequentially and then you have put it into that, and it cannot stay in order if you are doing addition. So, you will have to do some manipulations, and searching a file is you have to go to the block and then go to the overflow block also. This is an algorithm of how to read a file sequential, process all records, given the beginning address, you read the next record from the auxiliary memory into the main and process the record. So, you find that we have looked at how files are stored in memory, we have looked at typical physical allocation of files, we have looked at the taxonomy as access methods, and we have just peeped into what is meant by sequential files. So, we will be going into details in the later classes. Before we go further, you must know, and so some of the exercise you can do is try to understand and explain the differences between the 3 types of physical allocation methods, and try to find out, actually I have spoken about allocation and access method, what is actually the difference between the two, and try to think of some applications where sequential files are very advantageous. So, just look at these and answer this. So, thank you.